Hey, let's do a 2D example now of relative velocity. And I deliberately made this one a little bit sneaky, and I'm trying to mess with you a little bit. So I'm going to give you a second. It's problem 4.28 in the workbook. You can look at it there. I'm going to click some buttons real quick. If you want to pause the video and see if you can do it without me, that's fine. Great. Otherwise, let's kind of work through it here. So notice this one doesn't have a picture, so you got to read and pay attention. All right, one of the things that I can see here is I'm probably going to need a coordinate system. Now, while not strictly true, we usually assume the following unless otherwise specified. North is like the y-axis, east is like the x-axis, south and west are going to look like this. So, and I should be careful, east is like the positive x and north is like the positive y-axis. So having a picture helps you understand things, but also labeling them. So I'm going to look at this and I see that this is A relative to Earth. That's telling me VAE. Now it's 40 degrees north of east. That means start at east and go, what did it say? 30 degrees north of it. So north of east means start at east and then go north 30 degrees. And what did I say this was? This is velocity of A relative to Earth. Boy, we've got two capital E's here. Maybe I'll write east for this one, right? And east for this one. That way you can tell the difference between Earth and east. All right, and we see that that is some size 4.00 meters per second. Oh boy, I can tell I'm gonna have to do some SOHCAHTOA on that one. Fine, let's see what I got here. I have a drone following A, records B moving with this speed directed, oh my goodness. So what did I give you here? Well, if we read the next line, I hope you can tell I'm looking for B relative to Earth. That's a pretty big sign that I didn't give you B relative to Earth. And that's what I was deliberately being sneaky. Up till now, this blue vector has been the velocity of B relative to Earth. But you're supposed to read every time. And what happens is sometimes I'll mix things up on you. And this case is one I did. The drone is following along with A. So this is A and B is moving at this rate. So is this VAB or is this VB or is this VBA? Well, it's B is moving with this speed relative to A, which is where the drone is locked. So this is a fancy way of saying, let's see, A8 directed 50 south of west. So south of west means start at west and go 50 degrees this way. Well, that's kind of bad, but whatever. That's 50 degrees south of west. It's a little bit longer. I tried to draw it twice as long. This is 8.00 meters per second. And this is the velocity of, we better label this. This is the velocity of B relative to A. Okay. And what am I looking for? We want B relative to Earth. So this is how I would do that. Okay. You can do it any way you want. You can pause the video here if you want to see if you get it right. This is what I would do. I want this thing. I want VBE. So then what I would do is not think, I would get something on the paper, right? I could see that I need a B and an E. So the first term is going to start with a B. So I'll probably say that's going to be something like VBA. And I know the last letter has to be E, right? So that would be VAE. How do I figure this out? I know that B has to be the first letter, E has to be the last letter, and A is the letter that gets squeezed out this time. Are there other ways to do this? Sure. You could just guess until you get the right answer, but this is a systematic way of doing it. You label the thing you want. That gives you the order of the subscripts. And then from there, we can flip things around. Do I know VBA? Yes, we do. Oh, look, I know VA. So in this case, I got lucky. Normally you have to like flip things around and maybe do a minus sign, sort of like the last video, we had to like switch the order of the subscripts by introducing a minus sign. In this one, I think it's a straight up vector addition problem. So at this point, maybe you could see, do SOHCAHTOA on this. I'm going to do this as well. If you want to pause the video, that's great. Or maybe you can just figure out faster than me. I'm going to get my calculator out and try and do the math. Okay. So for this one, figure out which term gets sine and cosine, I think, and plus and minus sign. If you want to pause the video, last chance. Sine and 30 to half, that's 2. So when we're doing vectors, it's probably easiest to write it like that. I'm keeping a couple extra digits on this one, right? This is 2.000 because sine of 30, whatever. Okay, here, and this one over here, let's see, this is going to equal, see if you can figure out the I hat and J hat for that one. Okay, so if you're wondering where I got these from, this term was, I think, 8 cosine of 50, and this term here was 8 sine of 50, and then because this was going down and to the left, negative and negative for this one, over here, this particular one, let's see, 30 is adjacent to the x, so this was 4 cosine 30, and this was 4 sine 30. That's where I got this term and this term. All right, at this point, it's simply add up the I hats and the J hats and see what you get. You've got the answer in the workbook, but I've got a simulation here that does it for me. So after here, if you do the I hats with the I hats, let's just kind of approximately get it. We're going to get, oh, let's just do it. Screw it. If I add the two I hat parts together in this case, geez, in this case, so we're doing this addition. If I add the two I hat parts together, this is going to be how much in the I hat? Let's see. Negative 5.142 plus 3.464. I got negative 1678. The I hat, maybe I should keep extra digits, but I don't care anymore. All right, and then let's see, negative 6.128 plus 2, well, that's easy. So that gives me the I hat and J hat components. Is that what I asked for in the original question? How fast means speed. In this case, I need the magnitude of that. How do I get the magnitude of this vector? First term squared plus second term squared, square root. So basically Pythagorean theorem on these terms. So in this case, I'm just going to figure that out. So I want the speed, so I'm going to square this, square that, add them together, square root it. So let's see. Let's square that one plus 1.678 x squared. I'm going to square root that. And I got 4.46. All right. So let's look at the code really quick. You probably remember this from 2 videos ago if you're watching them all at once. So let's go to a screen share real quick. Let me get the code up. Here it is. So in this case, relative to Earth, that's where I get that 4.46 meters per second. The velocity of B relative to the Earth, which is the stationary coordinate system, is that. And I believe, whoops. So notice one of the pieces of information that you were given in the problem was this 8 meters per second. So what's crazy is I gave you information from one picture for B. I gave you from this picture for A, and you had to kind of sort that out. And that's the idea. If we look under the hood, just for fun, this video is done, but let's go ahead and look under here. Look at the equations that I'm using in here, right? While it seems a little bit crazy, this is kind of your basic relative velocity, right? And so if you switch the order of the subscripts, the sign flips, and then here is essentially the squeeze out, right? A, B, I use this equation for all of them. A goes to B. So A is the first one, B is the last one, E is the symbol that gets squeezed out because it's the third one, right? And that's basically the code. It's super simple. All right, but it's cool to be able to see how this might implement in the code, and I hope that's kind of fun. I'm gonna do one more that's